Welcome to Chapter 7, Concept 4. All right, so today we're going to talk about the quotient property. Quotient, remember, means division. So product we talked about earlier, and that means multiplication. Now we're going to talk about division, the quotient property. What do we do when we have exponents that are being divided? Okay, you have a base, you have an exponent, they're being divided. How do we handle that? Let's take a look. First thing you're going to do, just like before, is box all coefficients. Box your coefficients. Highlight the bases with the exponents. So just like we've been doing all along, highlight the base with the exponent. Remember, different bases, different colors. That rule still applies. Then you are going to divide or reduce the coefficients. Coefficients. Remember, the coefficient is the number that's out in front. So you're going to treat those numbers, the one on top and the one on the bottom, like they're their own thing. Divide them if you can, reduce them if you can, handle them first, get them out of the way. Then we're going to move on to the bases, because the bases are where the exponents are, and that's the tricky part that we're learning that's new. So, step 4. You are going to subtract the exponents from biggest to smallest, putting your answer where the biggest exponent was and keeping your base the same. I want you to stop for a sec and take a highlighter, and I want you to put a box around that step, because this step is the weird one. This is what's different. Although when you think about it, it makes a lot of sense. When we were multiplying, we added the exponents. Now we're dividing. Division is the opposite of multiplication. So what's the opposite of addition? Subtraction. So it makes sense that they kind of go together. Multiplication, we add. If they're being divided, we subtract. All right, lastly, as you're working with these, you should never have any negative exponents. If you end up with a negative exponent, something went terribly wrong. Go back to the top and start again. So let's take a look at some examples. First, we're going to take a look at 37. We have coefficient, base, exponent. Coefficient, base, exponent. Notice when there's a subtraction sign or a negative sign out front, it goes in the top. It goes up with the numerator. So I went ahead and put it up here to make it easy to see. I'm going to box my coefficients, box and box, highlight my bases with their exponents, and now I do the next step, the tricky step, the division step. I'm going to reduce or divide 2 over 3. Well, I can't do anything with that, so it's just going to stay negative 2 over 3. Now, I'm going to take my bases, focus on my exponents, and I'm going to subtract the exponents. The biggest, or subtract the smallest one from the biggest one. Well, I have 2 and 2. They're the same. So let me think. 2 minus 2 is 0. And we learned on the last concept that if the exponent is 0, then it's just 1. And we don't need to multiply by 1 because that doesn't change anything. So I can leave this off altogether. And my final answer is negative 2 over 3. Let's take a look at another one. 39. Here we have coefficient, base, exponent. Coefficient, base, exponent. If they already put the negative in the denominator, that's fine. You can leave it there because it doesn't really matter. But if it's out front and you need to put it somewhere, just put it up top. That's easy to remember. So let's go coefficients, coefficients, base exponent, base exponent. Okay, so 3 over 3. 3 divided by 3 is just 1. So this 3 divided by negative 3 is going to be negative 1. Now I look at my bases, focus on my exponents, 4 and 1, and I'm going to subtract biggest to smallest. So 4 minus 1 is 3. Where am I going to put the 3? I'm going to put it where the bigger one was. The bigger one's on top. So this is going to go on top. Now, down here, there's nothing really there because our negative 3 turned into negative 1 when we did the division here. And this p to the 1, well, we subtracted it from the top and put it up in the top. So this actually is our final answer, and there is no denominator. 41, we have coefficient, base, exponent. Base, exponent. Good. Coefficient, base, exponent, base, exponent. Okay, box your coefficients, box your 2, box your -4, and highlight your bases. A. Make sure that you are highlighting them the right colors, even though they're out of order. You want to make sure that you're grouping them correctly. So 2/4 can reduce to 1/2, and it's still going to be negative. Then I have A, 3 and 2. Well, 3 minus 2 is 1, so I know that the exponent on A is going to be 1, and I'm going to write it in the top because that's where the bigger exponent was to begin with. For B, I have 4 and 1. 4 minus 1 is 3, and I'm going to write it in the top because that's where the bigger exponent was to begin with. So 1a to the 1b cubed over 2, this is our whole answer. 43. Coefficient, base, exponent, base, exponent. Coefficient, base, exponent, base, exponent. But remember, these base exponents, because the exponent is 0, become 1. So this is 1, this is 1. They kind of cancel themselves out. Well, now when I look at it, I don't have any bases here. So the only thing that I have to worry about are my coefficients. My bases that remain are going to stay exactly the same. 4 divided by 1 is 4. It's a negative because this is a negative. So -4 and then x squared y to the 4th. And there is no denominator because both of these became 1. Now let's look at 45. We have coefficient, base, exponent, base, exponent over coefficient, base, exponent, base, exponent. Okay, so I'm going to box my coefficients, highlight my bases and exponents. Now it's time to do the division. -3 divided by -2. Well, the 3/2 doesn't divide or reduce, but the negative divided by a negative will become a positive. So when I rewrite this, it's going to be +3 over +2. And that doesn't change or reduce, so we can leave it that way. For x's, I have x cubed divided by x squared. So I'm going to do 3 minus 2 is 1, and I'm going to put that 1 in the numerator because that's where the bigger one was to begin with. For z, I have 2 minus 2, which is 0. That becomes 1, so I don't even need to put it in here. And there's my final answer. Now, for this last one, we've got lots and lots of bases, but that's okay. We can handle them one at a time. Coefficient, base, exponent, base, exponent. Coefficient, base, exponent, base, exponent, base, exponent. Box my coefficients. Highlight, let's see, M comes first because of alphabetical order, then P, then Q. All right, 1/4. That doesn't divide or reduce, so it'll stay the same. M to the 4th. I don't have any other bases that are M, so that one's just going to stay as it is down in the basement, down in the denominator. Now for P, I have 2 minus 2, which is 0, so my P turns into a 1. It becomes 1, and I don't need to include it. Q squared divided by Q squared, well, 2 minus 2 is 0. Q to the 0 power is 1, so that one's gone too. And here is my final answer. All right, let's take a look at one more, and then you can tackle the rest on your own. Number 46. Coefficient, base, exponent, base, exponent, base, exponent. Whoa. Coefficient, base, exponent, base, exponent, base, exponent. Whew, that's a lot. But we're not going to panic. We're just going to take it one base at a time. H comes first, then J, then K. All right, coefficients. 2/4 reduces to 1/2, and negative divided by a negative is a positive, so I'm going to have +1/2. Then h. I have h to the fourth and h cubed. So 4 minus 3 is 1, and I'm going to put it in the numerator because that's where the bigger exponent was to begin with. J. I have a 1 in the numerator and a 2 in the denominator. So this time I'm going to do 2 minus 1, which is 1, but I'm going to write it in the denominator because that's where the bigger one was to begin with. Oops, that should be a 1. Now for my k, again, my bigger exponent is in the denominator. So 4 minus 1 is 3, and I'm going to write that in the denominator because that's where the bigger one was to begin with. And that's all there is to that. So you take a look at the rest of these and come to class ready to discuss any problems that you have. I'll be happy to help. Have a great night.